Okay, so now we want to talk about the ice ages. So what do we mean by the ice ages? So it's going to be a period of time in which there was a lot more glaciers and a lot more ice on the surface of the Earth. So how far down did this ice extend? So in this picture here, it shows North America, and it shows how far the ice flowed southward. And so to give you an idea, the Missouri River in the state of Missouri in North America represents the southernmost boundary of one of these ice sheets. Okay, then another line of evidence that indicates just how far these ice sheets extended is from a physiographic map of North America. And so what this shows is the basic topography of North America. And you can't see anything from this picture unless I blow it up until it's really, really big. So I'm just going to keep taking this picture here and making it larger and larger until we can start to see some more features on this. But the interesting thing is that the topography of North America has been shaped by glaciers. Okay, so that if we were to take a look at this picture here, do you see this kind of a valley type thing that exists right here? Okay, notice that that's kind of an extension of one of these great lakes. And so during the ice ages, the ice sheet would have extended way down into here, and subsequently it has melted back into one of these Great Lakes here. And then also, if you keep expanding on this picture here, you will also be able to see some evidences of moraines. So like, for example, here's another one of those valleys right up here, and here's another one of those valleys, and then here's some areas where it pushed the material in front of it, and then when it melted back, it left that material behind. Okay, so just wanted to show you that. So how do we know that the ice ages have occurred? So old glacial features. So for example, if you go to the Rocky Mountains in North America, you'll notice that the valleys, instead of being V-shaped, and so that would be the original cross-sectional profile of a valley, and then the V part here was carved by a river. Well, you'll notice that a lot of the valleys in the Rocky Mountains in North America, instead of being V-shaped, are U-shaped, like that. And so that U-shaped profile was carved by a glacier as it moved through that valley. Another thing that you're going to notice in these valleys is that there is piles of debris in the middle of the valley. And so that is a moraine. It was material that was pushed down the valley by the glacier, and then when the glacier retreated back up the valley, then it left behind that material. So old glacial features. Another line of evidence is heavier isotopes of oxygen. So oxygen has different isotopes. So what do we mean by an isotope? Is that, let's say, in the nucleus of hydrogen, it consists of one proton. But then we found that there are other kinds of hydrogen. So there's another kind of hydrogen that consists of one proton, and then it's got one neutron in its nucleus. So they're both hydrogens, but they're different isotopes of hydrogen. So there are different isotopes of oxygen. In the nucleus of oxygen, normally it's going to have like 8 protons and it's going to have 8 neutrons. But there are other isotopes of oxygen that are going to have more neutrons, which is going to make that nucleus heavier. So it's a heavy isotope of oxygen. So when you've got water that's in the ocean and it evaporates, heavier isotopes are going to be left behind because they're heavier. It's going to be a denser water. And so that means that the lighter isotopes are going to be incorporated into the ice that's going to make the glaciers. And then the heavier isotopes that are left behind in the ocean then can be incorporated into the shells of marine organisms. And then when we find those marine organisms, we can date them using radioactive dating, and then to see how old they are, and then based on the number of heavy isotopes in it, we can figure out when was these heavier isotopes, when were they in the water. And so that would indicate when were the ice ages occurring. Okay, so when did the ice ages occur? So these dates come from radioactive dating of sediments. And so the top graph shows you the when the ice ages occurred throughout geological history. So over billions of years, there have been times when the Earth has been covered in ice. But the most recent time when the Earth has been covered up in ice is during the present time. So for roughly the past 1.6 million years, the Earth has been having ice ages. The bottom graph shows that period of time, roughly the last 500 million years of Earth's history expanded. And you can see that during that 500 million years, there have been times when the climate of the Earth has been hotter and times when the climate of the Earth has been colder, and during those cold spells is when the ice ages have been occurring. So what was the climate like during the ice ages? So the tundra extended to about 48 degrees latitude. So the tundra is going to be areas where you don't have very many trees, if at all, and it's all grasslands. And so today the tundra is up in Canada. But during the ice ages, it would have extended much further south than what it does today. Also, pine forests are able to withstand these climatic conditions better than deciduous trees. And so there was much more pine trees existed during the ice ages. There was much more rainfall in the United States, but rainfall actually decreased in the tropics. Here's a picture that shows some of the different kinds of animals that existed during the ice ages. And so, for example, you have the woolly mammoths, which were related to elephants, but they had a thick coat of hair that would allow them to exist during these cold spells. And then you also have things like saber-toothed tigers and giant sloths. So there were very large animals that existed during the ice ages. So what caused the ice ages? Let's take a break, and when we come back we will talk about this, because there's a lot of different components to the cause of the ice ages. So I'll see you in just a moment.